Okay, so if I ever did write a book called Confessions of a Bad Teacher, it would be a really, really thick book, and I apologize for that. But so here when we talked about sign, it's not even that big of a deal, but I feel like I can't leave it wrong. So this part right here, where we wrote in our zeros. So during second period, as I was writing it up there, I wrote integers, but I had this moment when I looked at that Venn diagram and I like second guessed myself. I thought, oh my God, I did that wrong, and I fixed it. The problem was really that I fixed the Venn diagram wrong. I mean, I read the Venn diagram wrong. I read it backwards. Plus, the second part of this, my resources that I was taking this from, and I just sort of copied part of it, even though I know better than to do that, part of it was wrong, and that's what really kind of threw a wrench in everything. So we're going to fix a couple of things. But this n times pi, so our zeros, we have one at 0 in every pi, right? So n times pi should make sense to you, right? It's every pi that it's happening. But it is an element of the integers, not the whole numbers. When I read the Venn diagram backwards, the whole numbers just start at 1, and it's your counting numbers, and I know better than that. All right, it includes 0. That's the difference between the natural numbers. The integers do include 0, and it's your positive and negative whole numbers. So the z is the integers. Now remember, I'm not going to ask you a whole lot of questions about zeros and weird notation like this, but we are going to write it down and talk about it, because this kind of notation is stuff that you're going to have to get used to in calculus and beyond. So, I mean, it's coming, so I'm sort of like giving you a little bit of a preview of this so that we can at least say it correctly. Okay? Everybody okay with that so far? So now let's look at cosine, see what we have to fix on cosine. This was why I got all confused, and I really messed this up, because with this n times pi over 2, I mean here, yeah, we're starting here at n or pi over 2, and I think we put on here n can't equal 0, because it can. If n was 0, that would be there. But honestly, it's not every pi n times pi over 2, because what if I substituted 2n? 2 times pi over 2 is pi, right? Do I have a 0 at pi? No, I do not. So this is the part that was wrong that made me question everything. So we're going to fix this. This is where you need your eraser, if you've got an eraser. Or you could mark it out. It is the element of the integers, but here's what's happening. Our zeros start at pi over 2, yes? And then after that, or even before that, they happen every pi. So pi over 2 plus pi is 3 pi over 2. So it's still every pi away, because all it is a translation, right? So I'm going to, it's pi over 2 plus n times pi. So basically it's just a shift, right? It's just like the other one, n times pi, but I have to shift it over pi halves. That's what your zeros are, okay? So hopefully that makes a little bit more sense. I'm sorry that it was wrong again. I kept trying to make sense of it. No wonder I was getting confused. I was focusing on the wrong thing being wrong. All right, we good? All right, let's look at tangent. Your tangent is blank. So we're going to fill this in. F of x is equal to the tangent of x, right? So what is the tangent of 0? 0. Bam. What is the tangent of pi halves? Undefined. How do I do undefined on my graph? How do we graph something where we can't graph it? What's that? Asymptote. Good. So at pi halves, I don't get to, x doesn't exist, right? And y doesn't exist, because a tangent of pi halves is undefined, so I have an asymptote there. Does that make sense? What's the tangent of pi? 0. What's the tangent of 3 pi halves? Undefined. What's the tangent of 2 pi? 0. Okay. So we've got the first quadrant done. Now let's go back a little bit here. This is 0. This is pi halves. What's the tangent of pi fourths? 1. So then this was pi halves. This is 3 pi fourths. What's the tangent of 3 pi fourths? -1. Then we have pi, that's 4 pi fourths. What's the tangent of 5 pi fourths? +1. So then this is 6 pi fourths, 7 pi fourths, -1. 8 pi fourths, this would be 9 pi fourths. What's that? 1. Okay. So let's get the first quadrant graphed before we do the rest of it. Do we know enough about graphing, asymptotes, intercepts, and whatnot to be able to sketch in our graph at this point? If this is an asymptote, that means something is approaching it, right? So if this is coming up here, it's going to be approaching it and keep going that way. This is going to come down and approach it and keep going that way, right? So in between these two asymptotes would be the easiest thing to graph first. It's going to look like this. You got a little point of inflection there. There's that section of the graph. Okay. So then the same thing's going to happen here, right? And then the same thing's going to happen over here. I just don't get all of it, right? These are not sinusoidal graphs because I can't make this into the sine function, but it is a periodic function, meaning that it repeats. Do you see how it repeats? So we should be able to graph the negative side of this graph just by following the patterns here. And we can get all this graphed in. We could have plotted some other points, but then we'd have to like estimate on the y-axis, and it's not worth it. That's enough to get us what we need. Okay. Everybody good so far? All right, so when we go to talk about the domain, there's a whole lot that lives in my domain, there's a whole lot that doesn't, right? But the stuff that doesn't work in the domain, does it happen at regular intervals? Yes, so if I start at 0, the first x that will not live in my domain is what? Pi halves, right? And then in another pi, it's 3 pi halves. And then another pi, and another pi, and another pi. So my domain, we're going to have to write this in set notation. Not interval notation would be a nightmare and kind of impossible. But it is all real numbers, but x cannot equal pi halves or anything with another pi added or subtracted from it, right? So there's your plus n pi again. Same idea. Pi halves are any interval of pi plus or minus that, where n is an element of the integers. Okay, you okay with that? What's the range here? -infinity to infinity. Good. We're going to change x-intercepts to zeros. So starting at 0, what's my first x-intercept? 0. And then they happen every pi after that, right? So this is just like it was for sine, n times pi, where n is an element of the integers. It's my y-intercept. 0, 0. Now, I didn't have any asymptotes in sine or cosine. I have a lot of asymptotes here, right? So I can figure out how to write that. Think about when we were doing rational functions. Your vertical asymptotes were everywhere your domain could not be, right? Well, not everywhere, but it depended, but that's kind of how that was. So this is the reason that x cannot equal these is because there's asymptotes there, right? So that means my asymptotes are x equals pi halves plus n pi, where n is an element of the integers. All right, so let's talk amplitude. What's the definition of amplitude?
The distance between the x-axis and the...
Okay, so that works when there's no translations, but technically it's half the distance between the max and the min points, right? So do I have max and min points here? No, if I don't even have them, I can't find the distance, so I can't find half the distance, so there is no amplitude. It is undefined. What is one period of a parent function for tangent? How far do we go before we repeat? It's just pi, right? So it's only from here to here before it repeats, or you could look at between the two asymptotes, it's only pi for tangent. Okay. Your transformations, f of x equals the a times the tangent of b times x minus c plus b. Amplitude. Okay, now write this small. We just talked about the fact that it is undefined, but write it right there because we're going to add something else here. We call it amplitude for sine and cosine because it's a trig thing. That's a trig word, but that's still the vertical stretch and compression, right? So although I don't have an amplitude, by definition it doesn't exist, I can still stretch this graph, right? So here instead I still have a vertical stretch or a compression, and that's still the absolute value of A. So A is still important. It's still going to stretch or shrink my graph. It's just not called the amplitude. Okay. The period, I have to divide by B, but I divide the parent function period, which is pi. So this time it's pi over the absolute value of B. And then these two are the same. Okay. Everybody good so far? Yes, sir. Dang it. Wait. Oh, up there. Dang it. One of these days I won't mess up. Maybe not. See, we're all human. That should be D. Thank you very much. Yes, Confessions of a Bad Teacher. Keep count. Be like a really, really big number. Okay, so I'm going to give you the second part of the notes. I didn't want you to have this yet because it shows the picture of tangent, and I wanted us to come up with it without you actually seeing it. Some of you may have seen tangent before, but I think most of you haven't, so. There's more. We got to graph some. Okay. Here we go. This is going on 107. So tangent function is undefined for certain values of x. Therefore, the tangent function has vertical asymptotes. They're not on this picture, so we need to graph them in because they are important. They should be there. Tangent function does not have an amplitude, right? And because, we are starting off with just our vertical stretch and compression and horizontal stretch and compression. We only have A and B in here, and then we'll add the others starting tomorrow. So, but if I have the A and the B in there, then the period is pi over the absolute value of B. Then we're going to talk about how we find where the asymptotes are. Even though there's a process, this isn't necessarily the way you want to do it when you're graphing. So it says the asymptotes are odd multiples of pi over 2 times the absolute value of B. Because although we're doing a lot of this graphing by counting, it's a good way to get the graph on there. If you needed to actually calculate what the values are, that is something you should be able to do pretty easily from, understanding the graph. But worrying about, where 4 pi sevenths is and stuff like that, that's not important. All right, so let's look at this graph. Let's graph it. It says identify the period, then graph each function, show the asymptotes on the graph. Okay, so it asks for the period. It asks for the amplitude for sine and cosine. It doesn't ask that. Though, because I forgot to take it off. But we still need something here because there's a 4 here. It's still important. So this is either the vertical stretch or the vertical compression. What is it? Stretch. So it's a vertical stretch of 4. Still an important thing. What's the period here? Pi. Okay, sorry. And then the part that, you can think about the tangent graph between the two asymptotes, but honestly, trying to get this stuff graphed, starting at 0 is usually a little bit easier for one cycle for all of these. So this, if we start at 0, this is what one cycle looks like, and this is going to help us get our key points in there. Since there are no vertical or horizontal shifts, 0, 0, just like with sine, I'm starting at 0, 0. So that gives this point. Then I would put this point here at the end of the cycle. One period is pi, so there's this other one. So now I've got those 2 points in there. Everything is symmetric. So halfway in between, I get an asymptote. Here's the asymptote. Then halfway in between the intercept and the asymptote here, this is where you'd have pi fourths, where the tangent of pi fourths is 1. But that's for a parent function. This is the number you use here, because that's you have to multiply that 1 times 4. So at pi fourths, I'm actually at 4. Which means at 3 pi fourths, I'm at negative 4. And if you've got that much in there, you should be able to repeat that pattern over and over again to fill up the graph. Okay? Do you agree with that? Any questions? Because now I've got this point would be this one up here. This point is this one down here. So then 2 away, I'm going to have an asymptote and then a point. Asymptote and then a point. An asymptote and a point. And then 4, 4, 4. Negative 4. Okay. So it looks like this. Okay. Everybody okay with that? Any questions? Ask me questions if you've got them. All right. Let's look at number 12 then. Number 12, is there a vertical stretch or compression? No. So I don't really call it either one, but I know that that 1 is important. What's the period here? 2 pi. And what else do I have going on in this graph? A reflection, because this is a negative right there. So this is my parent function, right? That's what I got to get put on there first, those important points. So I know I'm starting at 0, 0. The end of the period is at 2 pi. So I now have these 2 points on there. Halfway in between those two, which would be at pi, is an asymptote. Halfway in between this intercept and this asymptote, I'm going to have a y value of 1, but it's a reflection, so I'm here at negative 1. Halfway in between these two would be negative 1, but there's a reflection, so I'm here at positive 1. Okay, everybody okay with where all that came from? So I have this, basically. And then I need to repeat that. So this is at negative pi. And this is here at 1. So I have to back up or I'm going to get my points off. Okay, 2 over here, and I'm at negative 1. Oh, that's a negative 2. Dang it. Come on. Negative 1. And then I'm here. So it looks like this. Okay. Everybody good so far? My period, the distance between two asymptotes is 2 pi, or the distance between two x-intercepts is 2 pi. Okay. We good? Questions? All right. Let's try 13. Do I have a vertical stretch or compression? Vertical stretch of 5/2. What is the period? Pi halves. Okay, so here's my parent function. All right, so 0, 0, I start there. The end of the period is at pi halves, right there. In between the two, I have, so I've got this, In between the two, I have an asymptote. Right? So I got that taken care of. In between this intercept and the asymptote, I do not have a reflection, so I know it's going to be positive, and it's a positive 5/2, which is 2.5, so I'm right there. In between these two, it's negative since there's no reflection, and it's a negative 2.5. And since I have that much, I should be able to repeat this. I have an x-intercept every pi-halves. And I also have an asymptote every pi-halves. Totally just put those in the wrong place. Ask me questions if you've got questions. Anybody have questions? Okay, I'm going to give you some time to graph 14 on your own, and then we can look at it. But I know some of y'all are still drawing all those millions of little things in there. But for number 14, do you have a vertical stretch or compression? Stretch of 3. And what is your period? 3 pi-halves. Okay, so with that, go ahead and get that graphed in. I'm going to graph it without talking you through it after I walk around and see if you have any questions, and then we can make sure that we match. But I want you to try and get that one done on your own. Okay, once you have finished your graph, don't copy mine until you get yours done and then see if it's right. If you have any questions, let me know. If you're done with all that, then you can glue or tape this in. You only have 4 problems on your homework that have tangents. All that is due tomorrow. Unless you are having just some crazy difficult stuff, graphing, you need to talk to me individually. Don't just not turn it in. But you should be able to finish all these graphs that I gave you yesterday, including these, and it's all due tomorrow.